So in number 13, we had just figured out that our greatest common factor was 4r squared s. And we said that to find this other factor, you could do one of two things. You could either multiply or divide. See which one feels more comfortable for you. Is it easier for you to say 4 times what is 12 to get this 3? Or is it easier for you to say 12 divided by 4 gives me what to get this 3? However you do that is how you're going to want to do the rest of it. All right, so we could say r squared times what is r squared? That would just be 1. S times what is s cubed? That would be s squared. Or we could say r squared divided by r squared is 1, and s cubed divided by s is s squared. All right, then for our next term, same thing. We can say 4 times what gives me negative 20? That'd be negative 5. R squared times what gives me r cubed? That'd be r. And s times what gives me s? That would just be 1. 4 times what gives me 16? That's 4. R squared times what gives me r squared is 1. S times what gives me s squared? That's s. So there is our greatest common factor and what we have left once we factor it out. All right, then for 14, remember that our steps for factoring, step number 1, we're going to take out our greatest common factor. And then step number 2, we're going to look to see how many terms we have. If we have 4 terms, we're going to factor by grouping. If we have 3 terms, we're going to try to break that into 2 binomials. And if we have 2 terms, we're going to check to see if that's a difference of squares. So to begin with on this problem, there's no greatest common factor that I can take out. And so I'm going to try and factor this into 2 binomials. When there's a 1 out in front, I don't need to do the AC method. All I need to do is just list all the factors of my constant term. So my factors of 24 are listed here. And if this is a minus, I'm going to think difference, different. So I'm going to find the difference of my factor. And when I factor, my signs are going to be different. So the difference of 1 and 24 was 23. Difference of 2 and 12 was 10. Difference of 3 and 8 was 5. Difference of 4 and 6 was 2. So that's what we were looking for right there. We were looking for negative 2. Now, in order to get a negative 2, do I want this to be a positive 4 and a negative 6 or a negative 4 and a positive 6? Well, positive 4 and negative 6 would give me negative 2. And remember, the larger number needs to have the same sign as this middle term in order for me to get the sum that I want. So we can use positive 4 and negative 6 here. All right, look at 15. So again, I don't need to use the AC method. I just need the factors of 90. So we can say 1 times 90, 2 times what? 45. 3 times what? 30. 4 times what? Doesn't work. 5 times what? 18. 6 times what? 15. 7 and 8 don't work. 9 times what? 10. And the next one would be 10 times 9. So remember that once you start getting repeating factors, you know that you've got them all and you can stop. So because this is a plus sign in front of my constant, I'm going to think sum same. So I'm going to find the sum of my factors and my signs are going to be the same. They're either both going to be positive or they're both going to be negative. So we found all the sums. We remember we were looking for a sum of 19. So we found all of our sums and there it is right there. We want the 9 and the 10. So let's grab the 9 and the 10. I know my signs are going to be the same, either both positive or both negative. So what would I need to get a negative 19? Well, I would need a negative 9 and a negative 10. A positive 9 and a positive 10 would give me positive 19. So again, these signs are going to be the same and they're going to be the same as the sign of this middle term. All right, then for number 16, I start with looking, do I have a greatest common factor? There's nothing I can take out. And then I look at the number of terms that I have, and I have 2. So the only thing that we have studied that has 2 terms is a difference of squares. So if you'll notice, 9 is a perfect square, w squared is a perfect square, and 25 is a perfect square, and this is a difference. So yes, that's a difference of 2 squares. All right, so 9 is going to have to be 3 times 3. W squared would have to be w times w, and 25 would have to be 5 times 5. So again, we're looking for squares. We're looking for numbers that times themselves would give us that product. And then just like up here when we have a minus sign in front of our constant, that means our signs are going to be different. Same thing here. When I have a minus sign in front of my constant, for a difference of squares, my signs are going to be different. One sign plus, one sign minus. It does not matter if you put the plus first and the minus second. Either one of those would be fine. All right, then for 17, I started by seeing, did I have a greatest common factor? And there is no common number or variable for all of those. And then I looked to see how many terms I had. So I had 4 terms. And when we have 4 terms, we factor by grouping. So I'm going to group my first 2 terms, and I'm going to group my last 2 terms. So for these first 2 terms, I'm looking to see what they have in common. So if you'll notice, they both have a u squared. So I'm going to take out that greatest common factor of u squared, and then I'm going to see what I have left. And this is what we were doing up here earlier when we were saying you could either multiply or divide. So you can either say u squared times what is 7u cubed, or you could say 7u cubed divided by u squared. Either one would give you 7u. And then u squared times what is 2u squared, that would be 2, or 2u squared divided by u squared is 2. Now I'm going to do the same thing over here. So over here, I'm going to take out the greatest common factor. What's the largest number that divides into 42u and 12? And that would be 6. If you didn't know that off the top of your head, you could always come and do like what we did up here, where you could make your factor trees for 42 and 12, and you would find out that they have a 2 and a 3 in common. So that's where our 6 would come from. So again, we can say 6 times what is 42u, and 6 times what is 12. So the only way you can factor by grouping is if what you get right here and what you get right here are identical. So since those are the same, that's going to be my first binomial factor every time. That's going to be my common factor. And then we said, put your hand over this and put your hand over this, and whatever you have left will be your other factor. So what I would have left is u squared plus 6, and that's my other binomial factor. All right, then for number 18, I'm going to start by looking for the greatest common factor. I don't have one. This one has a leading coefficient that is not 1, and so in that case, that's when we used our AC method. So I'm going to say 3 times negative 4 is going to give me 12, and I'm going to give all the factors of 12. And just like before, if this is a negative, I'm finding the difference. If this is a positive, I'm finding the sum. So I found the difference between each of these, and I wanted a positive 1. There it is right there. And so to get a positive 1, would I want a positive 3 and a negative 4, or would you want a negative 3 and a positive 4? Well, to get a positive 1, I need a negative 3 and a positive 4. So I'm going to replace that 1q with what it's equal to, negative 3q plus 4q. The common mistake I see here is you put the negative 3 in the 4, but you forget to put the q with it, so be careful of that. Our purpose for doing that is now we've created 4 terms, and now we can factor by grouping, right? So let's group our first 2 terms, and let's group our last 2 terms. So in the first 2, we could take out a 3q. So if I said 3q times what is 3q squared, that'd be q. And 3q times what is negative 3q, that'd be negative 1. Or you could think about negative 3q divided by 3q, and that would also be negative 1. So don't leave that negative 1 off there. In my second pair, I could take out a 4. So if I take out a 4, 4 times what is 4q, that'd be q. And 4 times what is negative 4, that'd be negative 1. So again, to factor by grouping, these two have to be identical, and they are. So that will be my first binomial. So there's q minus 1. Put your finger over this one and your finger over this one, and what you have left is 3q plus 4, and that's your other factor. Your other option here would have been to factor by grouping. So if you'll notice 3q squared, that has to be q times 3q, and 4 could be 1 times 4, or 4 times 1, or 2 times 2. So I only would have had to try 3 things to find which one would work. So I could do this one by factoring with trial and error as well. All right, then look at 19. So here's another one where we have don't have a greatest common factor, and I do have a leading coefficient. So I'm going to do my AC method. So 2 times 7 would give me 14. Because this is a plus, I'm going to find the sum of my factors, and I was looking for 15. So there it is right there, the 1 and the 14. Now I need this to add up to a negative 15. So again, this tells me sum same. I know my signs are going to be the same. And in order for them to add to be a negative 15, they both need to be negative, a negative 1 and a negative 14. So I'm going to replace negative 15a with negative 1a and negative 14a. Don't forget your variable a. Group your first two terms and group your last two terms. Be sure you include the sign of that third term when you group. So in my first two terms, I can take out a greatest common factor of a, and I would be left with 2a minus 1. In my second two terms, I could take out a 7 or a negative 7. If I take out a 7, I'm left with negative 2a plus 1. This is positive 2a minus 1. Remember, they have to match. So if I had taken out a positive 7 and it didn't match, that would let me know to, hey, let's go back and try a negative 7. And sure enough, when I take out a negative 7, then they do match. So this common factor is going to be my first binomial factor. And then if I put my finger over this and my finger over this, what I have left, the a minus 7, is my other factor. All right, then for number 20, first thing I want to do is take out my greatest common factor. So you can see every one of these has a 4, or I could make a factor tree if I didn't recognize that. So I'm going to take out my greatest common factor of 4, and you literally can just put your hand over that and just bring it straight down as you're working on your problem. And let's just focus on factoring this. So now my leading coefficient is 1, so I can just make my normal list of factors. And this tells me that I'm going to find the sum. So I'm looking for a sum of 8. There it is right there. So I'm going to choose the 4 and the 4. Remember, sum's same. They're both going to be positive or both negative, and they're going to be the same as this middle term. So they're both going to be positive. And so that would be 4 times n plus 4 times n plus 4, or 4 times n plus 4 squared. So this is a perfect square trinomial. And remember, the way that we can see that is the first term is a perfect square, the last term is a perfect square, and if I multiply, since this was n times n and this was 4 times 4, if I multiply n times 4, I get 4n, and I double that, it gives me 8n. So we factored it without recognizing that pattern, but if you did recognize the perfect square trinomial pattern, that would be a shortcut for you to finish factoring this. All right, look at the next one. So for this next one, I don't have a greatest common factor, but I have two terms, and so I want to look for a difference of squares. So 81 would be 9 times 9, x to the fourth would be x squared times x squared, y to the fourth would be y squared times y squared, one sign plus, one sign minus. Absolutely, that's a perfect square and a difference between them. Now, our directions say factor completely because sometimes we're able to factor even further. So this first two terms is not a difference of squares because this is not a difference, right? So I can't factor that any further. But this second binomial right here, that's a perfect square, and that's a difference. I absolutely can factor that out. So 9 would be 3 times 3, x squared would be x times x, y squared would be y times y, one sign plus, one sign minus. So this would be our final answer. All right, then for number 22. Again, first thing I want to do is look for a greatest common factor. So you'll notice that I could take an 8 out of every one of these, so I'm going to take that out. You can put your hand over it and just ignore it and work the rest of this problem as if it was the only thing I had to work with. So ignore that 8 for right now. I've got 4 terms, so I'm going to group the first two and I'm going to group the last two. So for these first two, I could take out an m squared, and that would leave me with m plus 4. For these last two, I could take out a negative 1, and that would leave me with m plus 4. If I'd taken out a positive 1, it wouldn't have matched, and that would have prompted me to go back and look to see if I needed to change my sign. So since this is the same as this, we know we're going to take that out as our first binomial, and that would leave me with m squared minus 1 as my second binomial. If you'll notice, that's a perfect square, and that's a subtraction. That's a difference of squares, and so I need to factor that down completely. So m squared would be m times m, 1 would be 1 times 1, one sign plus, one sign minus. So when I look at my final answer, don't forget to bring that greatest common factor straight down into your answer. When I look at my final answer, this is a binomial, but it's not a difference of squares. This is a binomial, but not a difference of squares. And this is a binomial, but not difference of squares, so I know it's factored completely.